Welcome back to AI Builder Lab. In the first video, we learned what an agent is: model, tools, context, and typed output. In this lesson, we focus on the next practical question. How do we actually run the agent? We're going to use a ladder: complete, stream, observe, control, and keep that mental model throughout. When a topic is complex, the mistake is to present all the options at once, which creates a buffet of methods and leaves the viewer lost. Instead, we climb a staircase. First get the answer, then stream it live, then observe internal events, and finally take control of the underlying graph. At the end, we choose the right method for the job. There are 5 main ways to run an agent. Run_sync is the simplest blocking call. Run is the async version. Run_stream gives you the final output as it arrives. Run_stream_events gives you raw events plus a final result event, and it opens the underlying graph for node-by-node control. There's also run_stream_sync as a synchronous variation of run_stream. The key point is not to pick a favorite. The right method depends entirely on what you are building. This is the decision rule that prevents most of the confusion. If you only need the completed result, use run_sync or run. If you need a live answer in a user interface, use run_stream. If you need to see what is happening inside the agent, especially tool calls and partial deltas, use run_stream_events. If you need the deepest level of inspection or control, use iter. We are choosing a run mode based on the behavior our application needs, not learning methods in isolation. Let's start with the easiest method, run_sync. This is the method to reach for when learning, writing a quick script, testing a prompt, or recording a small demo. It is synchronous, meaning Python waits at that line until the agent finishes, and the final answer is onResult.output. Under the hood, run_sync is a convenience wrapper around the async run method. But as a beginner, you do not need to care about that yet. The async version, agent.run, does conceptually the same thing as run_sync. You give the agent a prompt and you get a completed result. The difference is the calling environment. If you are inside async Python code, such as a fast API endpoint or a background worker, you generally want await agent.run so the event loop keeps working during model and tool calls. This is not a different agent idea. It is the same completed run pattern in an async application shape. A helpful thing to remember is that a run does not just return a loose string, it returns a result object. In most beginner examples, we immediately print result.output because that is the answer we care about. But in a real product, you might also care about usage, metadata, messages, or the fact that this output must now trigger another workflow. The final answer is not just something for a human to read. It is data that the rest of your application can use. Moving from completed answers to live answers, run_stream is the method to reach for when you want the response to appear gradually like a chat interface. The agent is still producing one final output, but you can read the text as it arrives, so users do not have to stare at a blank screen while the model thinks. There is also run_stream_sync if you need a synchronous variation, and the job here is simple: stream the final answer. This is the first subtle part of the lesson, so let's slow down. In streaming mode, Pydantic AI can treat the first output that matches the output type as the final output. So if your output type is a string and the model starts producing text, the run may be considered complete even if the model also produced tool calls later in the streaming response, leaving those tool calls dangling. The practical beginner rule is, if tool execution must fully run and be observed, use run_stream_events or iter instead of plain run_stream. The event stream handler gives us a useful side channel. Think of it as 2 audiences watching the same run. The user sees the final answer stream into the UI, while your application sees the internal events, which can include the model starting a part, producing text deltas, starting a tool call, or receiving a tool result. This is useful for logging, debugging, and observability, while still using run_stream for the user-facing output. Run_stream_events is the clean way to consume the full stream of events. Instead of asking only for the final text, you iterate over event objects, and at the end you receive an agent.run result event that carries the final run result. This is the right method when you are building debugging views, tracing, custom logs, or anything where you need to know what the agent did internally, though the trade-off is that you now have more responsibility to piece together text or structured output from start and delta events. The event names can look intimidating, but they are just moments in a timeline. Part start event means a new part of the model response has started. Part delta event means a partial chunk has arrived. Function tool call event means the model is asking to use a tool. Function tool result event means your Python tool returned a result. Final result event means the model has started producing what it thinks is the final answer. An agent run result event means the whole run is finished. Do not treat this as a taxonomy to memorize. Treat it as a timeline you can observe. Now we reach the deepest level in this lesson, iter. Under the hood, a Pydantic AI agent runs through a graph, and normally agent.run simply traverses that graph for you. But if you need insight or control, iter lets you walk through the run node by node. You might see a user prompt node, then a model request node, then a call tools node, then finally an end node. This is more advanced, but it is powerful because it exposes the structure of the run instead of hiding it behind a single method call. There are two ways to use iter. The first is async for. You let the run progress and observe each node as it happens. The second is manual control with next, where you hold the next node, decide what to do with it, and then explicitly move the run forward, which means you can inspect or modify a node before execution, skip something in specialized cases, or catch errors around a specific node. My advice is to start with async for and reach for manual next, only when the product really needs that level of control. The most advanced pattern combines iter with streaming inside the nodes, giving you visibility into both graph steps and live events at each stage. When you hit a model request node, you can stream the model request. And when you hit a call tools node, you can stream tool call and tool result events. This is not where to start as a beginner, but if you are building serious agent observability, a teaching visualizer, or a debugging console, this is the kind of pattern you eventually reach for. When you use agent run, you also get access to usage, which matters in real products because agents cost money, take time, and may make multiple model requests or tool calls. You can check usage while the run is happening, and once the run finishes, agent_run.result contains the final agent run result and output. This is a production mindset shift. We are not just running an AI call, we are measuring an execution path where cost, usage, and final result all become part of the software boundary. The practical rule to remember is use the lowest power method that solves the job. If you are learning or writing tests, use run_sync. If you are an async application code, use run. If you are building a chat-like interface, use run_stream. If you need logs or tool visibility, use run_stream_events. And if you need graph-level control, use iter. A lot of agent code becomes confusing because people jump to the most advanced abstraction too early. Keep it boring until the product forces you to go deeper. To make this lesson stick, run the same simple prompt with run_sync and run, then stream a final answer with run_stream. Then print every event using run_stream_events, and finally use iter to list the node sequence. The learning goal is not to memorize every event class. It is to know which level of control you need for the product you are building. In the next lesson, we move from running behavior to configuring behavior, looking at how to shape what the agent does, not just how to execute it.